You. Really excited to be here. Thank you so much for the invitation. So I'll be discussing how AI is changing the game for cybersecurity and privacy. First off, what is privacy? Data privacy under the GDPR means empowering your users to make their own decisions about who can process their data and for what purpose. So it's really about giving control to the user so that they can make decisions about the data that they've produced. Generally, this is about their personal data. This often gets confused with data protection. Data protection really means keeping that data safe from unauthorized access. And data protection is a core part of data privacy. And cybersecurity is core to maintaining the protection of the data as well. So it's the practice of protecting systems, networks, and programs from digital attacks. So really all of these terms are very interrelated. You really can't have privacy without security, much like Anne Kabuki in The Creative Privacy by Design often says. And what cybersecurity and privacy are really about, one, it is compliance. So that is one reason why companies choose to pay attention. You've got PCI compliance on the payment card industry. You've got these data protection regulations popping up all over the world. You've got HIPAA that's been around for a while for healthcare. And then you've got things like SOC 2 compliance, where it's really about making sure that your entire network is safe when you're storing customer data or the data of other companies. It's also about customer trust. So we're seeing an increasing number of people who care about privacy, who will make purchasing decisions based on whether they trust a company or not. And there's a Cisco study from 2019 that says 61% of people said they won't buy from a company if they don't trust how their personal data is handled. We're seeing the number grow to 70% in later years, and it's really cool because people are starting to care. It seems like the GDPR may have triggered because they triggered a bunch of news about privacy, about what the rights are that people should actually have. People are paying more attention to this very important topic. And it's also about building better technology. So no one's going to give you their data set if they don't trust that you're going to keep it private. No one's going to give you their users' data because they themselves are going to get into trouble, or if your organization has a data leak, people are also much less likely to want to use your product. We can see this, for example, in the case of, Target, which closed its Canadian stores after its data leak in 2017, I want to say 2018, around there. I could be wrong about the date, but essentially there was a massive data breach, and soon after they had to close their Canadian stores. And it's also about peace of mind. So are you sleeping better at night because you've thought about your privacy and security protocols? It's a huge thing for CISOs and such. So in the privacy enhancing technologies toolkit, we've got secure multi-party computation that allows organizations to share outcomes of a computation, but not the original data. Homomorphic encryption, that allows people to send encrypted data to an organization. That organization computes on the data while it's encrypted, and they send back the encrypted results to a user or the original owner of the data, who then decrypts it. Then there's data de-identification. Data de-identification is about removing personal identifiable information, which includes both direct identifiers like names, full names, exact locations like social security numbers, credit card numbers, and quasi-identifiers, which are information that, when combined together, can increase the likelihood of re-identifying an individual exponentially. That includes things like age, religion, approximate location. So if you look at HIPAA, for example, it specifies what are for HIPAA Safe Harbor, what are direct identifiers? What are quasi-identifiers that you have to be careful of? One pretty clear example is location, for example. You can't have an exact location of a patient, but you can have state-level location information. So part of a zip code, part of a postal code. Then there's differential privacy that's being used. And that's being used, it can be used in two ways, really. One of them is when you're querying a data set and you want an approximate result. You don't want a very specific result because you're trying to make a generalization about a population without revealing the personal information from that population. So there's a data set of smokers and somebody in there has a rare disease, and you don't want to have an exact number of how many people are smokers with a rare disease that also have cancer, for example. But what you do want to know is how many smokers have cancer, if there's a correlation there. So you could query that data set and get, say, a 1, but you don't know if that 1 is actually a 1 or a 0 or a 2. So there's no way for you to know, have a membership inference about a particular person with a rare disease. Differential privacy is also used in machine learning. So for training machine learning models and making them not overfit on specific rare information. So the more that you see a piece of information, the less likely it is that it's sensitive information, unless you're dealing with very specific data sets. So a social security number, for example, is only going to appear, it might only appear once. If you're using differential privacy, it adds a little bit of noise to the training and prevents the model from memorizing that specific social security number. Secure enclaves are more of a hardware solution. They allow you to compute in a chip that is isolated from your operating system. So not even your operating system can look into it. Anything going into it is encrypted. Anything coming out of it is encrypted, and it's decrypted within the chip itself. And it does have some vulnerabilities because it is a hardware component. You can't have mathematical proof of security with a hardware component. However, there are often quite a few eyes looking at how to make these more and more secure as time goes on. And there hasn't been a scandal about them recently. Data synthesis is about generating new data, generally using AI for you to train your machine learning models on. The important part of data synthesis or synthetic data generation is also re-identification risk analysis, because when you're synthesizing data, you don't have necessarily such a good idea of how much personal information was kept from the original data. So it's important to double check that with re-identification risk scoring. And in the cybersecurity toolkit, generally this is more about access control, firewalls, antiviruses, threat detection. What's your username and password? Making sure those are strong, and managing the network as well. Often also making sure that you've got your network covered, so you're not at risk of data loss, for example. So that would be data loss prevention. And the cool thing here is that we could take from and transfer over to the privacy realm is the idea that none of these are perfect, right? Nobody expects any of these cybersecurity tools to be perfect. You're not going to stop using your antivirus because once it didn't catch a virus, it still caught quite a few viruses before it let one through. And it's also the idea of stacking. So we use a variety of these together to make our networks more secure. In the privacy space, oftentimes there's much more of a purism around what, if it doesn't work 1% or less of the time, then it's not good. Then you shouldn't be using that method. That is an incorrect way of thinking about privacy. You need to, just like cybersecurity, work towards making your data more private, and often stacking different security tools and privacy tools together in order to ensure that you're doing the best job possible. Now, where does AI come in? 80% of the data produced is unstructured, and there is tons of data produced every day. There's no way we can make sense of it without AI. So how are we going to protect it? First of all, what AI allows is for more fine-grained access control and also data minimization. So more fine-grained access control, for example, if you're using NLP to query a set of data, you don't necessarily need, for example, the postal codes in the data or the social security numbers in the data in order to have your machine learning models be trained on sentiment analysis or named entity recognition or so on. So NLP can help redact the personal data and the quasi-identified information within text, within images, within video, and within audio, making that data more portable within your organization in a more secure way. So part of the GDPR, for example, is keeping track of where personal information are stored, how are they being processed. And if you remove that personal information in the first place, you've got much less of a headache to deal with, but you've also got a much more secure setup because you're not spreading that information around in your organization and ending up not knowing where it lands. Is it on somebody's private laptop and so on? Then there's the concept of data minimization is also within the GDPR. You're only supposed to gather the amount of data that you need, the amount of personal data that you need for the amount of time that you need in order to perform the task that you promised your user you would use it for. And AI helps you get there by removing all of the information that would otherwise be toxic to your environment and that you don't need for your tasks. Then there's better network management that AI can help with. So more on the cybersecurity end of things. NLP can help identify the quasi-identifiers and personal data that are flowing through a network. You can't use things like just regular expressions oftentimes because you can picture something like somebody talking in a transcript, hey, my credit card number is 549. No, wait, it's 352. No, that's a 5. There's no way you're going to create a regular expression that's going to catch those as credit card numbers. You need AI to be able to identify those. Computer vision can also help with that. So looking at faces, license plate numbers in both images or video, also AI for audio. There's this data categorization aspect of things. What it really lands on is having models that are very generalizable and very fast. So what PrivateAI is doing on the privacy side of things is, for example, data pseudonymization in a natural way. And so we can detect personally identifiable information and quasi-identifiable information within text, within images as well, and replace it with very similar looking data. And there are two benefits to this. Number one is the privacy is increased. So if anything is missed, it's very difficult to tell what the original data was from the fake data. Number two, it adds to the naturalness of the data set that you're working with as a machine learning engineer. So you are pre-trained, the models that you're using in NLP are pre-trained on a ton of very natural looking data. And when you train on redacted data that isn't natural looking, it does lead to a certain amount of machine learning accuracy loss downstream. And so having this natural looking data does prevent that from happening. We've tested this in sentiment analysis, we've tested this in named entity recognition, and a few other NLP tasks. And we do intend to publish some work on that at some point. And for cybersecurity, I want to give you an example. Let me share a terminal window. So can you see that okay?
It's wonderful on my screen.
Great, thank you. So,
and we have 2 minutes,
okay.
3 minutes, okay.
Okay, perfect. So what you've got here is a message from a cancer message board. And what you put into the API call that you send to a REST API that's hosted directly on your server is the text that you want to either redact or detect personal information from or pseudonymize. And for cybersecurity specifically, oftentimes what's used is this dictionary of personally identifiable information, which contains the type of label that was found and also the confidence score associated with that label, and it can get pretty specific. Now, I'll go back to the core presentation. Now, we're able to do this with 99+% accuracy for in-domain accuracy for a huge variety of verticals because our NLP models have been trained on such varied and robust data sets. And what we're seeing is that we're getting a lot of inbound from financial institutions, insurance companies, from conversational AI companies who are interested in either minimizing data or working on categorizing their data better because the solutions out there tend to be based on regular expressions, or they don't want to build it in-house, or the solutions out there are just not fast enough or not robust enough. And what we see is complementarity in cybersecurity and privacy, which is really come alive in the kind of work that we do. And these two cannot live in vacuums. You really need both to make your network secure. And AI, what we're seeing is the next step towards regulatory compliance and information security, just because of the massive amounts of very messy data that need to be dealt with. Thank you very much. If you're interested, there is a privacy enhancing technologies decision tree in the PrivateAI website that you could take a look at if you're wondering what kind of privacy technology is right for you.